Right, so this is Specs 101 once again. For some of you it might be surprising that I'm tackling the same problem again. However, there are a lot of new people here that will start their journey with testing soon, or they have already started it. So I think it might be okay to summarize the aspects of testing backend applications in our systems. And a few years ago, when we were not testing that much, or at all, no, I'm just kidding, but I thought it was like everybody does that. Well, every company do tests, and we don't, so we suck. But actually now, I think that this is what differentiates us, that we are doing tests, we have test suites, and other companies don't do it. And I think this is the real thing, because so many customers that we are dealing with came to us with some ready projects. We asked where the specs are. Oh, we didn't write them, right? So, so now we cannot live without it. So, and that's a good thing. So, back to the topic, Specs 101. So, just a short reminder of testing practices that we have tried and used in CDO. First thing to ask yourself is what to test, right? So, it's just a short list. The first thing that is worth testing is the thing that customer wants, so features. We usually use Capybara or some Cucumber specs on some projects, and this tests the basic behavior of the application or for a solution that doesn't go into details. But it's really worth testing because it ensures that everything works well. The main thing works fine. Controllers, it's obviously specific for MVC apps, but we are talking about Rails here. So controllers are worth testing because they are easy to test. But maybe let's skip the reasoning behind. Let's just summarize what can be tested at all. So there are like services, queries, forms, and collections. These are the things that interact with controllers very often. So we call services, we ask for some data from queries, we initialize forms for views, we prepare some collections to be represented in a view. So this is something that lives close to controller. The next thing that lives close to controller are representers, serializers, and policies. So can we do it? How can we represent the data that we have prepared, etc. Right? There are models. We do not often cover our models with extensive specs because many things in models are macros, like relations, validations, and they are, well, are they worth testing? You should ask yourself, but this is something that we usually skip because it has low value. And there are decorators, something that influences the views, just as helpers do. And this is most often tested by the feature specs, so that's why it's so low in the list. And there is JavaScript. And JavaScript, well, it's a different story, so I won't tackle it here, but, well, it's important. So, in relation to those, like, services, representatives, models, and decorators, helpers, we have to put big attention to just test public interface. I know that on some projects we have exceptions that we cannot control, but if we have control, the role of a thumb is to test only public interface, so no private, no protected methods should be tested directly. They can be tested indirectly by testing public methods. I have not mentioned it about controllers, because in controllers, yes, we sometimes test their methods directly, but usually just call requests. So I don't think that's a good example to wrap it within this current bracket. Anyway, you know what I mean, I hope. How much to test? Well, if we are testing feature specs, the problem is that they are slow. They execute for quite a bit of time. So our decision, at least on the project I'm working on, is to test happy paths and sometimes some alternative paths if they are worth testing. But we do not test like the edge cases. Controllers. This is the best place to test the initial edge cases. So we know that already our system is interacting with this controller by testing it through feature spec. And now we can control, hey, what happens if I hit this controller, well, with this kind of data, which is valid, what should happen? Maybe it should return some API error, that's it's unprocessable entity, or something. So controllers are easy to test because they are easy to call. You always have the same interface to call them, like send a request to a controller and expect some changes, expect some result. So they are easy to actually comprehend how to test them. So how about services and queries and forms and collections? Because those are the objects that most of your logic lies within. And if there is a logic involved, then it's good to test as much as possible. So test all edge cases, all behaviors or interactions with external services, as like wrappers, etc. So in my opinion, testing everything from grounds up, and services, queries, and forms and collections, and some other objects that you might use, is a good way to go. And over here, test-driven development makes its full potential. So, but about that, we will tackle it a little bit later. So, representative serialization and policies. Well, depends on your approach. For example, if you really care about permissions, you can test policies a lot. But representatives and serializers, they usually just dump data. And if the data is okay, well, testing every single parameter, if it's dumped properly, it might be a bit tedious. So we have decided that we don't always test those, but if there are some logic pieces that might be worth testing, well, we do it. What about models, decorators, and helpers? Same thing. Because helpers, they are slightly tested through feature specs. Same goes with decorators. And models, a lot of things, models, as I have already mentioned, are macros. So there are things that are tested within Rails. So we might test how we use them, but isn't it already tested by feature specs and controller specs and services, queries, etc.? So many things in those low-level objects are already tested indirectly. So don't write the same spec for the same thing just to check if your relation works. It might be not important, unless you are very Nazi about it. How to test? So there are like two approaches, or three. We can go for maximum readability. So our goal here is to allow other coders to get to our project, read our specs, and actually sort out what they are doing. It's even more important when somebody is fixing your spec. Because, well, you can say, oh, I pretty know what this thing is doing, but when you try to fix it, it's where does that come from? I mean, what's this figure, right? But on the other hand, we can go for maximum optimization. So you can have like 1,000 lines long spec, and you can have a spec that does the same thing that's, for example, half in size. Question is it okay? Is it right? Is the way to go? Or maybe we should mix those two approaches. Do some of this, do some of that, and it's your decision where to go. But let's maybe show some simple comparison. For example, over here, it's just providing some data for a spec. I mean, for an example. So if we go for optimization, we can just use let. It's one-liner. So cool, we love one-liners. And within actual example, we can just use it by its name, just to check if it exists, right? If we went for readable way, we don't hide it somewhere in the top of our file. But under our expectations that use it, we just define it as a method. It's just a regular Ruby method, so there's no magic about it. That's why we think it's more readable. And in my opinion, it is. Because there is no additional layer that actually sets your tests up. It's a simple difference, but when the spec grows, it actually makes a difference. Another thing is, for example, this described class code here. Well, in the optimized way, we do not want to repeat things, right? We are testing this user class, so why to repeat this user every time? So we just go for described class and refer to the class being described as name calls. But in our readable way, we repeat this class name here. What's good is when we are like in the middle of a class, it's a huge spec, 500 lines long, we always know what's being tested. We always know that user is being tested and its class method of being active or not, or maybe it just returns an array of active users. But we can always refer to it directly in an example that we are looking at. So that's why it's more readable. Subject thing. So in optimized way, we, for example, testing user. So we can define, hey, our subject will be user, so I will build it and use it later on in specs, that will a bit shorten our expectations, because we can call it like that. It is expected to have attributes named default. However, if there are a lot of the single line expectations, you can sometimes forget what the subject is, especially if you change it during the way because you are using more context, etc., etc. Subject changes, so you need to know what the subject is, and you might be misled, you might be actually wrong. That's why, in a readable approach, we just define a subject or an object that we are testing directly in an example. So when reading a singular example, you can always know, oh, I'm testing that. I don't have to think about it. I don't have to imagine what is there, because I have it right here in a setup of a given example. So there is no chance to be wrong, right? In this particular example, it's even pushed a little bit further. So let's think that we are testing if our UUID is set for every new object that we create. And we do it for, wow, 25 models. And so I think, I'll use this super nice feature of shared examples. And we have included one example over there. We just check if the after object is created, if its UUID field is not nil, or just present. And then in all our specs for the given classes, we just include those examples. However, the problem is here. Has default ID? Right. Well, you probably know what does that mean. But usually, when we use this feature, we tend to make some more complex things. And usually the time comes when you think, what does that mean, that it has default ID? And you go to a shared example and you read it, aha, okay. And now you face those. Let objects, some more preparation, some subject alteration, and you see, wow, I don't know what this variable is here. I mean, what it represents. And in the readable way, we don't care. We just repeat the same test. So we don't care about sharing of expectations. In a readable way, however, we use custom matchers. Those custom matchers, well, if they express something in a more readable way than the default matchers, then it's still okay. And we still have this focus on singular example testing. So I recommend the readable way. This is how we approach our project. It comes at a cost because our specs are longer, our test setup is longer as well, but you can always tackle the problem with a spec very easily because you don't have to think about too many things. Just you are always in the scope. What are the other things that you might consider? You can have a look at betterspecs.org. There are some things that go for this optimized way, like use X, use subject, use describe class. However, there are some things that we still use. For example, singular expectations. If we have a spec that prepares some data, we don't want to test every aspect of this result. We usually tend to test one thing. Well, does the record count change? Does this object have proper fields after creation, etc., etc. However, nothing stops us from doing this thing. If the testing is actually very well connected, so for example, we have tested that a new user appeared by changing the count of objects in the database, we can check if the fields are right. It's very close to each other, but just do not overuse it, right? It's important to create only the data you need, because if we ask ourselves why this test is so slow, it's probably because we use our database a lot, so we create a lot of stuff. So our factories are configured in a way that creates a lot of additional objects. So if we can just create only the data that is needed for a particular example, maybe we do not even need to store it in the database. Maybe we just need to initialize an object and test it on its memory-based version, right? So keep that in mind to keep your test sharp and fast. Use factories and not fixtures, like your database probably should be empty when you run your specs. Maybe there are some reasons for it not to be in some kinds of specs, but if it is possible, just use factories and create everything on demand. So you don't have to remember that there is something in the database. You should start with a blank slate and just create everything precisely what's needed for a behavior to be tested. Yes, context is another thing. Context gives us a textual information of what we are testing in which environment, under which conditions. And in this optimized way, under each context, there is some code that actually clarifies the context. So for example, when logged in, then we add some before callback that logs us in. However, in the readable version, we just put everything within a singular spec. And that's a difference, but it's not represented here. The last thing is, for those who just started their journey with specs, is how to describe, because we usually describe something. So we usually test methods. This is the primary thing that we test. So if we are testing the class methods, we use a dot in a beginning of the method name. If we use test instance methods, we use sharp in the beginning of method name, and that clarifies us what kind of method that is. Almost last thing, when to test. So this is not like a guide that you have to follow, but usually when we are delivered with some acceptance criteria and this feature is well defined how it should work, we start with the outside-in approach. So we just test general behavior first, then go a bit deeper, test controllers, and if we need additional edge cases tested, we go even deeper, etc. And if we think that additional specs are not worth it, then we just stop. And this is how we implement most of the stuff. Test-driven development is like everybody does that, but not really. This is actually possible and fun to do when you have all things, all expectations clearly defined. So you know how it should work from a logical perspective. So just write tons of spec, like 25 for one class, and you just fill them, fulfill them. And it's really cool, especially when there are calculations involved, etc., etc. So I really like it, but under some conditions. And there's always this situation with just don't know how to do that, and you would like to hack around something. So writing specs might be not that easy and efficient to do. So I usually just hack around, make a class or two, delete those, make other classes, and assemble this way and that way, and only then add some tests. And I don't know, I have nothing against this approach. So it's up to you, what philosophy do you prefer? However, I think the mix of all those three is quite reasonable to follow. Where to test? Obviously, we all test locally at some point before we push it to external CI. Some people use guard to keep our tests running all the time. We don't. We just test the thing that we test at the point at which we decide. But, well, up to you. And then we push it somewhere else to run the whole suite, because it usually takes a couple of minutes or more. And there's two solutions that we've used in the past, probably more, but these are the most popular ones. It's Travis CI and Circle CI. Circle CI is better, but because it has this SSH logging, so everybody at some point in time will face a situation when your tests pass locally, but they do not pass remotely. And well, it's really cool to actually be able to log into this instance that fails and check it out there. So that's why I recommend Circle CI, even though it's a bit more expensive. Nothing. Okay, that's cool. So thank you.